Please title these notes Derivative 7 Notes, Other Trigonometric and Exponential Functions, and write today's date. By the end of this lecture, you should know the derivatives of some of the trigonometric and exponential functions that we haven't worked with yet. Really, this is just mainly a memorization lecture, so here are some more derivatives to memorize. First one, the derivative of the tangent of x is secant squared. And remember, if you've forgotten, so the secant of some number is just 1 over the cosine of that number. Cosecant is 1 over the sine, and cotangent is 1 over the tangent. That's all these mean. Our next one is that the derivative of the secant of x is secant x times tangent of x. Next, the derivative of the cotangent is negative cosecant squared, and the derivative of the cosecant of x is negative cosecant times cotangent. There is no good way around memorizing these. Really, you just want to look for patterns. For me, I noticed that tangent here has 2 secants over here, and on this one we've got 2 secants and a tangent as well. Same here, we've got a cotangent and 2 cosecants, 2 cosecants, and a cotangent. That kind of helps me orient myself a little bit. I also noticed that the derivative of the co-functions, cotangent, cosecant, we have a negative out here in front. I noticed that there is a certain amount of parallelism here, tangent and cotangent right here, turn into secant squared and cosecant squared. Basically there's just a co in front here. Same thing here, secant and cosecant, secant and cosecant, tangent and cotangent. So I sort of look for patterns like that, but really probably the best way is just to recite them to yourself a bunch of times. Look at the paper, then cover them up, recite them some more. Just kind of got to know these ones. There are 2 other ones you kind of just got to know. Let's take the derivative of some number to the x power. This is similar to the derivative of e to the x. Remember that the derivative of e to the x was just e to the x. But this is some other number. Let's call it 2. And when we take the derivative, we're going to have what we would expect to have if this was e to the x, but it's going to be times sort of an adjustment, the natural log of whatever that number is. So, for example, if we wanted to take the derivative of 3 to the x, what that would be 3 to the x times the natural log of 3, whatever that decimal is. Similarly, let's say that instead of taking the derivative of the natural log, log base e, we're taking the derivative of some other base, log base a of x. Now we remember that when this was natural log, log base e, the derivative was simply 1 over x. And what we find here is a similar pattern, 1 over x, but we have sort of an adjustment because this isn't base e. The denominator is x times the natural log of whatever this base is. So for example, if we were taking the derivative of log base 3 of x, that would be 1 over x times the natural log of 3, whatever that base is. These rules here, they just got to be memorized. There's no way around them. So I would pause the video for a little bit, make yourself some flashcards, quiz yourself on them, get your significant other to quiz you on them, get your cat to quiz you on them, you know, whatever. These just have to be memorized when you come in tomorrow. Let's do some practice problems with these, and then at the end I'm going to go back and show you the proof of why these ones are what they are. It's most important to be able to just memorize them and know them off the top of your head, but I do want you to see where they come from because it's kind of interesting. First though, let's go do some examples. Let's start off with taking the derivative of 3 times the tangent of x minus e to the x. And all of the rules that we used earlier apply. So once again, this 3 is just along for the ride. So we got 3 there. And now we just got to know our rules. The derivative of the tangent of x is secant squared x. So down here this is going to be secant squared. And we know that the derivative of e to the x is e to the x. Stays the same. Bink. We're done. For our second one, let's say that f of x equals the secant of x times 2x to the 5th, and we want to figure out what the derivative is. So here again we're going to use the same rules that we have before. It's just that now we've got this additional sort of piece that we've memorized that we can use. So the first thing to notice here is that this is the product rule. We have 2 functions that are multiplied together. Here's our f and here's our g. So what we're going to use when we take that derivative is we're going to be using that f prime g plus fg prime that we've used before. So we're going to do the derivative of the secant of x, that's f prime, times plain old g of x. And then to that we're going to add f and then the derivative of 2x to the 5th. Now the only thing that's new about this is that now when we see this derivative of the secant, we have memorized what that is. So f prime of x, the derivative of the secant is secant times tangent. This 2x to the 5th is along for the ride. Here we've got this secant of x, and now we take the derivative right here by bringing down the exponent. 2 times 5 is 10. Subtract 1 from the exponent, x to the 4th. There we go. Sometimes with these really long ones, you'll also see people factor out whatever is in common in both terms for their final answer. So in this case, we see a secant x in both terms. We see that there is a 2 in both terms. We see there's an x to the 4th in both terms. So sometimes you'll also see people write this as f prime of x equals secant of x times 2x to the 4th. And then just whatever we didn't factor out is left over. So we didn't factor out a tangent of x. We didn't factor out an x right here. And we pulled out a secant of x, 2x to the 4th. We didn't pull out a 5 over there. So some people are going to write that like this. That's also perfectly correct. With the AP test, they don't care if you simplify or not, so we'll typically stop there just to save time. We can also use the quotient rule with this. So let's say we had a function y equals 2 to the x power divided by the tangent of x, and we want to find the derivative, then we would say that the derivative, in this case we're going to use the quotient rule, so that's f prime g minus fg prime over g squared. We're going to take the derivative of 2 to the x power, and we're going to multiply that by plain old tangent of x. We're not taking the derivative. And then we're going to subtract 2 to the x power times the derivative of the bottom, derivative of tangent of x. Then all of that is going to be over the denominator squared. So it's a little bit nasty to work with, but it's okay. The derivative of 2x we just saw over here. It's like the derivative of e to the x, but we have to have the natural log of whatever the base is in there too. So we're going to have 2 to the x power times the natural log of 2. All of that times the tangent of x minus 2 to the x. And then the derivative of tangent we said was secant squared x, coming straight from our list again. All of that divided by tangent of x squared. So let's have you do 2 check for understanding problems. The first one I want you to do is to take the derivative of f of x equals the secant of x divided by x. And the second one I want you to do is if y equals cosecant of x plus 5x to the third minus log base 3 of x, I want you to find the derivative. So find the derivative of those two and then restart the video when you're ready. Pause the video now. Here's what I get. For this one we have to use the quotient rule. So we're going to do the derivative of the top times the bottom minus the top times the derivative of the bottom over the bottom squared. Derivative of secant is secant times tangent. Derivative of x is x to the first power, so when we bring that down it's just 1 x to the 0, or 1 times 1. And then convention, typically we're going to write that x in front of all this just so it's a little more neatly spaced out. But if you leave it right here, that's fine. Over here we just kind of got to remember what they are. Cosecant, that derivative of cosecant is negative cosecant cotangent. Here we bring down the coefficient, subtract 1 from the exponent. Here we're going to do 1 over x just like we do for natural log, but we've got this adjustment of 1 over x times the natural log of 3. That's what you need to be able to do for tomorrow. As just a little interesting thing, I'm also going to show you the proof that the derivative of the tangent of x is secant squared x. This is something that is interesting. It's not something you're going to have to do, but I thought I'd show it to you because it shows you in general where these come from. So there are a couple of things that we need to remember. The first thing that we need to remember is that the tangent of x is the same thing as the sine of x over the cosine of x. So when we say we want to find the derivative of the tangent of x, that's the same thing as saying we're finding the derivative of the sine of x divided by the cosine of x. Remember, this is just the quotient rule. So what we're going to do is we're going to do that f prime g minus fg prime over g squared. When we do that, we're going to have the derivative of the sine of x times cosine minus sine times the derivative of the cosine all over cosine squared. Remember the derivative of sine is cosine, so what we have here is we have cosine of x times cosine of x minus the sine of x, and we notice right here the derivative of cosine is negative sine, all over cosine of x squared. So here we have cosine of x squared plus sine of x squared all over cosine of x squared. And one of the things you kind of have to brush out of your memory from pre-calculus is that the cosine squared plus the sine squared is just 1. And we also have to remember that 1 over the cosine of x is the secant. So 1 over the cosine of x squared is the secant squared. That's where this comes from. Now, on the AP test with limited time, you don't want to be spending your time deriving all of that out. Just memorizing from here to here is totally fine. One important convention to remember in all of this is that something like secant squared x, that just means you take the secant of x and you square it. Same thing here. Cosine squared x is the same as cosine of x in parentheses squared. Do remember that this is different than if you have the cosine of x squared with the squared right next to the x here. That means that you square x first and then take the cosine. Here we're talking about doing the cosine of x first and then squaring it. This concludes the notes for derivative 6.